Introduction, a method of analytical chemistry that aims to find the elemental composition of inorganic compound is classical qualitative inorganic analysis. It focuses primarily on detecting ions in an aqueous solution. A cation is an atom charged positively. An atom is electrical neutral, and it is because it equals the number of protons and the number of electrons in atoms. Objectives. Number 1, to be able to identify the action of group reagent. Number 2, to describe the destruction of ammonia complex compound. Number 3, to identify the extraction of cupric ion and mercuric cation. Number 4, to measure out the separation of copper sulfide and mercury. Number 5, to be able to identify the use of cupric iron, mercuric cation, cobalt, and nickel ion. Procedure. The cupric ion, mercuric cation, and cobalt and nickel ions are the cations of the D element. The electronic structure of 4 cations is distinguished by presence of pre-D orbitals. The majority of compounds are soluble in water such as sulfates, chlorides, nitrates, and acetates. The reagent of this group of cation is a concentrated solution of ammonia that forms soluble ammonic complexes. Of this is on how the destruction of this compound along with a 6M solution of sulfuric acid and the perception of copper and mercuric cation sulfides along with the activity of crystalline sodium thiosulfate and the solubility in nitric acid and bromine water. The use of complexing food oxidizing reaction is the resolution of this analytical group cation. The cupric ion, copper, cobalt, and nickel ion form colored compound while the mercuric cation is not forming colored compound. Step number 1. 10 to 15 drops is the measurement of solution in that small test tube. Then add 30 drops of 20% aqueous ammonia and it will form ammonia complex compound. Step 2. For destruction of ammonia complex compound, add 2M sulfuric acid to the solution. The color of sulfuric acid or H2SO4 is colorless oily liquid. It is soluble in water and release heat. For the extraction of cupric iron and mercuric cation, add crystalline sodium thiosulfide to the solution and heat the test tube in the boiling water for some minutes. Then separate the precipitate by using confuge. Sodium thiosulfate is an organic compound with the formula of sodium thiosulfate. It is colorless and transparent crystal that used by utilizes for decoloration. Step number 4. Add 5 to 7 drops of 2M nitric acid to the solution and the copper sulfide brings down will dissolve and become the cupric ion, while the mercuric sulfate and sulfur going down is dissolved by bromine water. Nitric acid is the colorless or pale yellow liquid acid that is corrosive and poisonous and has a strong oxidizing properties. The copper sulfide going down will dissolve by nitric acid because copper is oxidized by concentrated nitric acid or NHO3 to produce cupric ions. Mercuric sulfate going down is dissolved in nitric acid because it is insoluble in all concentration of nitric acid as pure compound. Step number 5. To identify the colored cupric ion, add 8 to 10 drops of 25% aqueous ammonia to the solution and add some drop of supernatant. The formation of blue solution indicates the presence of cupric ion. The reaction between cupric ion and aqueous ammonia will form color blue of aqueous cupric ion to combine the copper sulfate and ammonia solution. Thus, equation for this reaction is copper sulfate plus ammonium hydroxide goes to ammonium sulfate plus copper hydroxide. Color blue comes from copper complex ion or CuH2O for OH2. Step number 6. To dissolve mercuric sulfate going down, add 6 to 8 drops of bromine water where the sulfur going down is not dissolved. The result of mercuric sulfate going down, once bromine water is added, it becomes mercuric chloride. Step number 7. Measure out the precipitate into small test tube from 0.6 and add 6 to 8 drops of water of bromine. Heat the test tube for a few minutes in bath of boiling water. Separate once by configuring the precipitate and add just one drop of supernatant iodine. The presence of mercuric cations is indicated by the formation of red precipitate that is soluble in reagent excess. Step number 8. For the identification of copper cations, add a little crystal of ammonium thiocyanate and amyl alcohol to the sulfonate. The result of blue organic layer will indicate the presence of cobalt cation. Step number 9. For the identification of nickel cations, add few drops of 25% aqueous ammonia and dimethyl glycoxime. The result of strawberry red formation indicates the presence of nickel cations. The reaction entails two dimethyl glycoxime molecules appearing as chelating markers to form a nickel dimethyl glycoxime square planar complex. This response is very touchy and can be used as a affirmation test of the presence of nickel cations even in very low concentration. And that's all. Thank you for listening. God bless.